looking at homework problems, exercise 10D, further derivatives. Find the values of x for which the second derivative equals 0. So we've got u is x, u dash is 1, v is x plus 1 to the half, and v dash is a half, x plus 1 to the negative a half times 1. So first derivative, y dash is uv dash plus vu dash, which is x times a half, x plus 1 to the negative a half plus x plus 1 to the half times u dash is 1. And then we take out the common factor of x plus 1 to the negative a half, and we're left with a half x, or x on 2, plus you've got x plus 1 to the power of 1, which is x plus 1 to the negative a half. This is a half x plus 1x, which is 1.5, which is 3 on 2x plus 1. That's your first derivative. Your second derivative, you're going to have to do uv dash plus vu dash again, because it's product rule. Your u is x plus 1 to the negative a half. Your u dash is negative a half, x plus 1 to the negative 3 on 2 times 1. Your v is 3 on 2 x plus 1, and your v dash is just 3 on 2. Second derivative, u v dash. So what that would be, x plus 1 to the negative half times 3 on 2 plus v is 3 on 2 x plus 1 times u dash, it's times negative a half x plus 1 to the negative 3 on 2. Now, so we've got the common factor is, the only common factor that I can see, there's two of them, would be the 2 on the denominator here, unless you want to multiply through there. Oh no, yeah, girls, you can't pull out, this is that's that times negative a half. I would probably just pull out a half, and I would pull out x plus 1 to the negative a half. That's what you pull out. So there's the half here, but then you're going to have a 3 left here. So you've got 3 plus 3 over 2x plus 1 times x plus 1. Sorry, the negative 3 on 2, sorry, I've made a mistake, is the smaller power. I've pulled out the wrong one. So negative 1.5 is smaller. So I need, so the half comes out, x plus 1 to the negative 3 on 2 comes out. So we've got 3 bracket x plus 1 to the power of 1 here, because negative 1.5 plus 1 is negative a half. So that's the first term. The second term will be minus. And I've got minus, be careful, this is the second term, this whole thing. So I've got the half is already out. The x plus 1 to the negative 3 on 2 is out. The minus isn't. So I've got minus this 3 on 2 x plus 1. So I've got a half x plus 1 to the negative 3 on 2. And then when I'd expand this, 3x plus 3 minus 1.5x. Wouldn't that be 3x minus 1.5x is 1.5x. 3 minus 1.5 is 1.5. So I've got 3x plus 3 minus 1.5x minus 1. So I've got a half x plus 1 to the negative 3 on 2. I've got 3 on 2x plus 2. Now we've just got to put that equal to 0. Now I'm going to write that as, put this on the denominator, the negative index. So I've got the 2 on the denominator. This x plus 1 to the 3 on 2 is on the denominator. And on the numerator, I've got 3 on 2x plus 2. That's what I've got. You okay with that? So now putting y double dash equals 0, we'll put that equal to 0. So we've got 3 over 2x plus 2 over 2 times, this is the square root of x plus 1 cubed equals 0. Now the only way that is going to be 0 is if the numerator is 0. Denominator is not allowed to be 0. Therefore, 3 on 2x plus 2 is 0. And so 3 on 2x is negative 2, which means that x is negative 4 on 3. Because times 2 divided by 3. Because d squared y by dx squared is the second derivative, but dy dx squared is not the second derivative, it's the first derivative squared. Okay, so let's just write out what we've got. Let's do our first derivative. Dy dx is, what, 4 bracket 2x minus 1 cubed times 2, which is 8 bracket 2x minus 1 cubed. The second derivative is just 24 2x minus 1 squared times 2, which is 48 2x minus 1 squared. Left-hand side is d by dx of y times dy dx. So it's the derivative of y times that. So we've got to go equals d by dx of y times 8 bracket 2x minus 1 cubed. Got a bit of a problem there. That looks a bit weird. What do I need to do with this y? Replace it with what y is, which is d by dx of, I'm going to put the 8 out the front, then times y, which is 2x minus 1 to the 4. You got what I'm doing? And then times 2x minus 1 cubed. Oh, what do we do there? Bases are the same. Add the indices. 2x minus 1 to the power of 7.
Oh my God, I got it right.
So we're differentiating 8 times that. So let's go. So 8 times 7 is 56. 2x minus 1 to the power of 6 times 2, which is 112. 2x minus 1 to the power of 6. That's your left-hand side. You know to replace the y here for the following reasons. You want to differentiate with respect to x, but you've got a y there. So you've got to go back and see what y is, and you can write y in terms of x here. Okay, and that fixes that up. And then on the right-hand side, we've got y times d squared y by dx squared plus dy dx all squared. What I might do, yeah, that's okay. So y, let's just substitute it in straight away. It's 2x minus 1 to the power of 4. The second derivative is 48 bracket 2x minus 1 squared plus dy dx is 8 bracket 2x minus 1 cubed, but you've got to square that. So that's dy dx, and then we're going to square it. So again, bases are the same. Add the indices. 48 times 2x minus 1 to the power of 6 plus 8 is squared. You get 64. When you do a m to the n, don't you multiply the indices? So you get 2x minus 1 to the 6. And hopefully 48 and 64 are 112, and I think they are. 2x minus 1 to the power of 6, which equals left-hand side. So therefore, it's true. Okay? Find the first, second, and third derivatives of x to the power of n. So if y is x to the n, is that what you did? Y dash is nx to the n minus 1. Y double dash is n times n minus 1, x to the n minus 2. And y triple dash is n minus 1, n minus 2, x to the n minus 3. So part B says to find the nth and the n plus 1th derivatives of x to the n. Watching. First derivative, you've got an n minus 1. Second derivative, you've got an n minus 2. And then it's n times n minus 1. It's times all the others before that are higher than that. Look at the third derivative. You've got to look at the pattern. N's in n minus 3, and at the front of the x, you've got an n minus 1, n minus 2. So if you want the nth derivative, wouldn't it be n minus n? And you'd have it multiplied by all of them down to n minus 1. Because it's got to be, look, this is n minus 3, and that's one number less than 3 is the last one. So yes, it's going to be multiplied by n minus 1, by n minus 2, let's keep going. But it's then got to be n minus, the last one should be n minus 1 smaller than that 3. Third derivative is n minus 3. Second derivative is n minus 2. The nth derivative will be n minus n. So it should be n times n minus 1 times n minus 2 dot dot dot. The one, I'm just going to leave this here for a minute. We might put 2 more before it. The last one will be n minus n, right? Has to be, which is 0, which is 1. This should be n minus 1 less than that n, but in brackets, n minus 1. The one before it should be 2 less than the 3. So this will be n minus 2, right? Do you see how I'm doing it with patterning? So then we go n times n minus 1 times n minus 2 dot dot dot. Well, what's this? Isn't that just a 2? N minus n is 0 plus 2. So that's just times 2 times 1. Basically, you're starting from times 2 times 1 times x to the 0. See, I'm going to show you something in a minute, which is basically, isn't that n factorial? X to the 0 is 1. The answer is n factorial. Are they doing it as n factorial or no? They're just writing it like that. But it is n factorial. Can you see? N times n minus 1 times n minus 2. So it's n times n minus 1 times n minus 2 times dot dot, all the way down to 1 times 1. That is n factorial if you want. Now, so when do you think, you know, n is just a number, isn't it? N is just a number. So these are all numbers. If n was 10, this would be 10 times 9 times 8 times whatever. Whatever this whole number is, when you differentiate a constant, this is now a constant. When you differentiate a constant, what do you get? 0. Or you can say, isn't this y to the n? You know what I mean? Y to the, I don't know how I show that. To the nth, you know what I mean? It's not actually y to the power of n. It's y to the, this notation, I shouldn't write it as y to the n. It's y with n of those, you know, dashes. I'll just go, well, you know, n of these. You know what I mean? Or I'll just go the nth derivative, really. Now, that's a constant. See how the nth derivative is this? You know, with differentiation, you bring the 0 to the front. So if I even continue from there, the n plus 1th derivative, let's say I decide to use this line here. Isn't it n minus 1 times n minus 2 times 2 times 1 times, don't I bring the 0 to the front? X to the negative 1. Now, if I just multiply anything by 0, I get 0. Or I could say the nth derivative is 0 because the n plus 1th derivative is 0 because the nth derivative is a constant. This is a constant. So therefore the n plus 1th derivative is 0 because the derivative of a constant is 0. Because if the nth derivative is a constant, if I say to you differentiate 2, you get 0. There are no more powers of x to drop. Well, you've really got x to the 0. You bring that down, you get 0 times x to the negative 1. Do you get this? Do you get this bit? All right? All right, now I'm going to show you just with a small example. E.g., if you've got y equals x to the power of 4, it means that the 4th derivative should be 4 factorial and the 5th derivative should be 0. Right? You ready? Y dash is 4x cubed. Y double dash is 12x squared. Y triple dash is 24x x to the 1, y 4 dashes is 24. That's 4 factorial, which happens to be 4 times 3 times 2 times 1. And the fifth derivative is 0. Find positive integers a and b such that x squared times the second derivative of y plus 2x times the first derivative of y equals 12 times y. We know that y is x to the power of a plus x to the power of negative b. So let's do what the first derivative is. Y dash is, we're differentiating with respect to x. Don't you bring the a to the front? X to the what? A minus 1. Plus you'd bring the b to the front, so it's negative b, x to the negative b minus 1. That's what y dash is. All good? Y double dash, again bring the a to the front, the a minus 1 to the front. A minus 1, x to the a minus 2. All good? And minus b times negative b minus 1, x to the negative b minus 2. I think, is that what I'd got done yesterday? We can clean this up a bit. You've got a times a minus 1 times x to the a minus 2. You know, this is looking very much like what we were just doing in question 11. B and a. Notice the pattern. Look, negative, negative is a positive, negative, negative is a positive. I'm just going to go plus b bracket b plus 1 because do you think that would give me negative b times negative b is plus b squared? Negative b times, or you would pull a negative in common out and negative, negative is positive. Can you see that? Negative b.
Plus b squared plus b.
Yeah, you can expand. And I'm going to put x to the negative. You can put negative b minus 2 or negative bracket b plus 2. I'm not sure yet what we'll do. Okay. All right, yes, we can expand if we want. Let's do that. A squared minus a x to the a minus 2 plus b squared plus b bracket x to the negative b minus 2. Right, so let's just substitute in. Left-hand side, let's do right-hand, left-hand side is x squared times the second derivative plus 2x times the first derivative. So it's x squared times a squared minus a times x to the a minus 2. Bracket, big bracket, because it's x squared times all of that, plus b squared plus b times x to the negative b minus 2. Plus, that's just x squared times the second derivative, plus 2x times the first derivative is a x to the a minus 1 minus b x to the negative b minus 1. So I'm just substituting, not manipulating yet. Okay.
And that equals 12.
Well, x squared times that, yeah, I will do that in a minute. I'm just going to get an answer for the left-hand side and then get one for the right-hand side. So what's x squared times this? Look, bases are the same. Don't you add the 2 plus a minus 2? That's what you do. X times x squared times x to the a minus 2. The bases are x. Add the indices. So this is what I've got. A squared minus 2 times x to the 2 plus a minus 2. Do you get what I've done? I'm multiplying this by that, by this whole term. Well, the a squared minus a stays at the front, but the x bases are the same, so you add the 2 and the a minus 2. Plus, again, same thing here. B squared plus b times that x squared. The x's are the same, so I add the 2 with the negative b minus 2. Plus, now that's expanded, plus 2x times this, so 2 times a is 2a. This is x to the 1. So bases are the same, 1 plus a minus 1. I'm just showing the working. Oh, sorry. That's x. 2a times x to the 1 plus a minus 1 minus 2b And again, the bases of the x's are the same. Add the indices, 1 minus b minus 1. Do we get this? These are terms, x squared times that whole thing, 2x times that thing, 2x times that term. So what do we get? A squared minus a times, what do you get here? X to the a plus b squared plus b times x to the negative b plus 2a x to the a minus 2b x to the negative b. Now I've got like terms. X to the power of a's are like terms. So I've got a squared minus a of those plus 2a of those. They're the same thing. So I've got x to the a squared minus a plus 2a. Do we get this? These are like terms. It's like a squared minus a is the coefficient of x to the a here, or pretend they're x squared terms. That's the coefficient of that x squared term. That's the coefficient of that x squared term, but they just happen to be x to the a's. So these coefficients you add together, plus x to the minus b, they're like terms as well. And you've got b squared plus b, take away 2b. Sorry, I know I should space this one out a bit more. I'll just space it out a bit more. Minus 2b x to the negative b. Can you see like terms there? So now we've got x to the a squared plus a, and we've got x to the negative b squared minus b. All right, let's work on the right-hand side. Right-hand side is, and then we're going to put them together. Right-hand side is 12y, which is 12x to the a plus 12x to the negative b. Now we're going to solve the equation. Left-hand side equals right-hand side. So therefore, x to the power of a squared plus x to the minus b squared minus b equals 12x to the a plus 12x to the negative b. What are you going to do now? Oh, this is fun. You're going to have two quadratics that you have to solve both of them. So let's take the x to the a over. So I've got x to the a bracket, a squared plus a. What's this going to be when I take the x to the a over? Isn't it a common term? Do you know what I'm doing? Minus 12 in brackets plus x to the negative b squared minus b. When I take this over, I get minus 12 as well. Equals 0. I took everything to the left. Do you get what I've done? That'll be an x to the a term as well, but it'll be minus 12 x to the a, and the other one's minus 12 x to the b, and then I'm taking out x to the a and x to the negative b as a common factor. So for that to equal 0, so now we solve these quadratics. So couldn't x to the a be 0, or a squared plus a minus 12 equals 0? That's how this whole thing's going to be 0. So we've got a squared plus a minus 12 is 0, or b squared minus b. I think you need and or. Oh, they're the same. They're the same. They're the same equations. So one of them is going to be a, one of them is going to be b. When you factorize this, you get a plus 4, a minus 3. So a is negative 4 or 3, and you get the same here. In other words, one of them's a and one of them's b when that happens. Oh, yes, we want the positive integers. So therefore we've got that a is 3. Got it the wrong way around, not reading it properly. So this should be b minus 4, b plus 3. So we got positive 4 or negative 3. Therefore, a is 3 and b is 4.